Hi everyone, welcome to our presentation on the applications of chemistry in the petroleum industry by Harvey and Philip Bo. First of all, let's take a look at what is petroleum. It is a complex mixture of hydrocarbons in the earth, and they occur in liquid, gaseous, and solid forms. Commonly, we refer to these as crude oil. Petroleum is formed from fossils and sedimentary rocks from billions of years ago, and these include natural gases and bitumen, which are viscose and solid forms of hydrocarbons. Now let's go back in time and take a look at some traditional uses of petroleum. Back in the times of the ancient Greeks and Egyptians, petroleum was used as medicine. The Persians then distilled crude oil to obtain flammable objects for weapons. The art of distillation into luminance became available to the Europeans in the 12th century when the Arabs invaded Spain. During the times of colonization, oil was discovered by many explorers in many parts of the world.
Here are some modern uses of petroleum. The process to distill kerosene, which is clean liquid formed from mixture hydrocarbons, was invented in 1850s. It is the major step to produce fuel. The first commercial well was drilled in Poland in 1853. The first oil well drilled in North America was in northwestern Pennsylvania by Edwin Drink in 1859. Nowadays, fuel has become the major supply of energy for automobiles. Currently, more than 60 million barrels were transferred to consumers every day.
The petroleum industry nowadays refers to the global processes of exploration, extraction, refining, and transportation. This could be divided into three streams: the upstream, midstream, and the downstream. There are many products produced in this industry. The most important ones are fuels, gasoline, lubricating oils, and petrochemicals. The petroleum industry could be divided into four major steps. Exploration involves the finding of petroleum by geologists and other scientists. Extraction involves the extracting of petroleum from the earth by using different kinds of methods. Refining, where the crude oil obtained goes through a process and is refined into more useful petroleum products such as fuel. And last but not least, transportation, where these products are transported to the consumers. Before we go into deeper details about the petroleum industry, we need solid background information about hydrocarbons and organic chemistry. So, crude oil substances are mainly composed of hydrogen and carbon, which makes up hydrocarbons. And in crude oil, the percentage of carbon is around 82 to 87%, while hydrogen is about 12 to 15%. Molecules is up to 4 carbons are gaseous, 20 or more are solids, and those in between are liquids. In complex hydrocarbons, hydrocarbon groups will replace the hydrogens or stack the rings. On the right hand side, we have the simplest hydrocarbons in crude oil. In chemistry, saturated hydrocarbons refer to those chains or rings with full complements of hydrogens. These are known in the petroleum industry as paraffins or paraffinic hydrocarbons, while in chemistry they are referred to by chemists as alkanes or cycloalkanes. More specifically, straight-chain hydrocarbons are known as normal paraffins. Those with branches are isoparaffins. Finally, the ring types are referred to as cycloparaffins or naphthanes. On the other hand, unsaturated hydrocarbons refer to those that does not have a full complement of hydrogen in their rings or chains. Unsaturated hydrocarbons are characterized by having two adjacent carbons linked by a double or triple bond instead of a single bond. These bonds are actually weaker, making unsaturated hydrocarbons more reactive than saturated ones. Straight or branched chains in an unsaturated hydrocarbon with at least one double bond is called an alkane or a monoolefin. Hydrocarbons with at least one triple bond is called an acetylene or an alkyne. Olefins and acetylenes are produced in the conversion processes of crude oil in a refinery, and this is a very important step for making petrochemicals. Now, ring compounds with one or more 6-member rings with alternate double bonds is known as aromatics, as stated in Chapter 1. They are called aromatics due to their specific smell. Complex aromatics could also be obtained by replacing the hydrogens with hydrocarbon groups or by condensing or stacking rings. Other complexities could be caused by the introduction of other elements such as oxygen, nitrogen, or sulfur. In crude oil, the hydrocarbons present are mostly alkanes, cycloalkanes, or some aromatic hydrocarbons. These could be grouped into three series: the paraffins, naphthalene, and the aromatic series. And in different types of crude oil, there are different proportions of the three series. So let's start off with the alkanes and paraffin series. These are also called methane series because methane is the most simple structure in the series. These are all hydrocarbons with single bonds, and the series comprises of the most common hydrocarbons in existence. And the saturated straight chain for this series is the formula CnH2n plus 2. Alkane series usually exist as liquids at normal room temperature, but they would boil between 40 and 200 degrees Celsius. And the series are the major constituents of gasoline. The naphthalene series has a general formula of CnH2. This is a saturated closed ring series, and they are an important part of all liquid refinery products. This series forms most of the complex residues from high boiling points, therefore this series is generally pretty heavy. The residues of the refinery process is known as asphalt, and these are the high molecular fractions of petroleum. The dominated crude oils in this series is known as asphalt-based crudes. The aromatics, on the other hand, has a general formula CnH2n-6. This is an unsaturated closed ring series, and the most common one is benzene by the formula C6H6, and is present in all crude oil. Typically, the aromatic series constitute a very small percentage of crudes. There are three general types of crude oils. Paraffin-based contains a higher molecular weight paraffin, and these produce high-grade lubricating oils. The second type, asphaltic-based, contains large proportions of asphaltic matter, and they tend to yield a lubricating oil. The last, mixed-based, is sort of like a gray area in between the two above, and these contain both paraffins and naphthalenes, and most crude oils fit into this category.
All or most of the nation's oil comes to refineries. A refinery is simply that, a place where crude oil is refined into the many kinds of petroleum products we need. Crude oil is a mixture of compounds, and here it can be separated into the petroleum products consumers and industries want, and the ones that are most valuable in the marketplace. When you look at a refinery, most of the distinctive towers you see are tall distilling towers like these. The shorter stacks, vessels, and equipment are used in the many other refining processes. The oil comes in by pipeline, and condensates may come in by tank truck. Normally they go first to a distilling unit. The distilling process is based on a simple fact. The hydrocarbon compounds that make up crude oil have different boiling points. Just as water eventually would boil off and become vapor at the boiling point of water, 212 degrees Fahrenheit, these compounds also have points where they flash or vaporize. By determining just what that temperature or temperature range is, refineries can harvest many desirable hydrocarbon products from a single batch of crude oil. Chemists know that lighter oils boil or vaporize at lower temperatures, but it takes very high temperatures to reduce the heaviest oils and their solid carbon residue to vapor. Each batch of crude oil is different and will produce a different set of fractions. When these compounds leave the distilling tower, most go on for further processing. Butane and lighter gases may be sent to gas processing. Straight-run gasoline for motor gasoline blending. Naphtha for catalytic reforming. And kerosene for hydrotreating. Light gas oils will be sent for distillate fuel blending, and heavier oils to what is called a cat cracker, where heavy molecules can be broken apart to yield lighter compounds. And straight-run residue, the solids or heaviest residue of the crude oil, can be sent for high-heat flashing. Some of the fractions of crude oil that left the well site go on for still further processing at a petrochemical plant. This plant may turn crude oil fractions or their cracked or processed derivatives into the feedstocks that will be used to create the many products we need today based on oil. Plastics, detergents, solvents, fertilizers, synthetic rubbers, and synthetic fibers.